Can you guys hear me okay? You're good? Okay, cool. Let's see what I'm talking about today. So, like I said, Mike Goffin. A lot of people call me Sir. Some people just call me MJG. It's my initials. What I'm going to talk about today is a little bit about malware and how you can do identification and classification of malware using Yara, specifically with Python. They have a lot of bindings with other languages and APIs for whatever you need, but specifically for ease of use, Python. A little bit about myself. I went to RIT. I graduated in '06, and I was a member of Computer Science House while I was there. There's a few of us here. And currently, I work as an InfoSec scientist engineer for a government contractor. I won't go any further into that. So like I said, we're going to be talking about malware, Yara, Python, the classification stuff. I have some demos for you to show you how you can use Python to do some analysis on certain pieces of or test files we'll consider malware for the sake of argument, and then a little QQ session if anyone wants to cry or complain about anything I talked about. So, malware, sweet son of a bitch. We see malware in a ton of different file types. You know, PDFs, Swift files, Windows executables. You have Word documents, Excel files, rich text. I mean, the list goes on and on. These are just some of the major types that you'll see malware coming into your network embedded in these files. Some of the ways you get these acquisitions coming through are downloads off the internet. Now, this doesn't necessarily mean someone's going to a web page and downloading a file. This can be through BitTorrent. You know, Dropbox has been pretty popular lately. Whatever way someone actually attempts to initiate a download onto the computer of some type of file. Compromised website content. If I pop a website, I can easily replace any file I want on there with malicious content of my choosing. And I don't necessarily have to make them the same file that you've seen. I could have an image on there or a PDF on there that looks like a PDF or an image, but once it's on your machine, it's actually something completely different. Another way you get it is through email. Phishing scams all over the place, emails pretending to be your bank, and you click on the link, it looks like your bank, it really isn't. You just loaded a web page, it's now malicious, and the content is on your machine. You know, attachments are rampant all over the place. I'm very, very paranoid with attachments now, but any attachment that comes in, if you don't know who the person is and you haven't validated that that email came from them, you don't necessarily know that that attachment is what it says it is. So let's say I have a scenario where you've been infiltrated. Most of the time, you don't know this has happened, and you're going about your day-to-day, and so is somebody else on your network, and you don't know about it. Another huge thing, you don't know how big a scale the infiltration has become. You know, in the first day, maybe it's a box or 2 or 10. Over time, if that person's seeding themselves, they're going to move laterally, and they're going to acquire as much space on your network as they can to root themselves. That way, if they do have an issue where you find their machine, you take it off the network, they still have another box that they can get into your network with or use to acquire information. And then we move on to the severity piece. Well, how deeply rooted are they? What do they know? How do they know it? How deeply rooted are they in all those systems? And how much access do they have to all the things that you want to keep people out of? For the sake of argument, let's say someday after you've been rocked, you see something that seems a little bit confusing, so you want to try and find out what it is. Everyone should be very familiar with this ridiculous cycle. The theory being that your preparedness will save you from everything. And really all that means is that's how bad you've done. That's the bar that you've set. So when you fail, you can see how little you've actually done to protect yourself. So what winds up happening is you come into response, and now everyone's all worried. This is where management starts flipping out. All the people start asking questions. No one knows the answers. People start trying to do things they think are going to help, and they're really just kind of stumbling through because they weren't actually prepared. They didn't have a plan. So you get through that really long response time, and then you move into recovery. Well, how do we get them off the network? How do we clean our network? What do we do from here? Install patches, change passwords, yada, yada. And then you run through your mitigation steps so you can get back into your preparedness. Well, what can we do to better protect ourselves so next time this doesn't happen? The unfortunate thing is you start to get tunnel vision, and now what your mitigation steps are is literally focused on what just happened and not about the bigger picture. So now you're safe from that one specific incident, which is probably never going to be used on you again because it was already used. The tricks out. Like I said, management wants answers, and this is pretty much the response you get right away. No one has any idea what's going on, and no one has those answers because no one's had the time to go through and do the analysis. So what do? You panic. You start going through all these random things that you think are going to help, but they're probably not, and you're probably doing them in the wrong order. You know, taking hosts off the network, making everyone in the company change their passwords, changing every password for every web service you have, every administrative account you have, and, you know, trying to go through anything you can think of, whether it's IDS systems, antivirus, logs, running network traffic analysis, whatever you can think of, just to make it seem like you're doing something that makes it feel useful. Usually doesn't happen. Most important step that everyone usually skips is acquiring the malware so you can analyze it. You've been rocked by a piece of software and you don't want to know what it did. You're trying to go through and do all these steps to clear your network and make it secure, but you didn't actually find out what the malware did in the first place. If you knew what the malware did, it's much easier to figure out where on your network it is, where it could have gone, where it's rooted, and how to get rid of it. So we get better at data mining, and we use all these steps. Who is interested in your company? Who is interested in that targeted user that might have gotten that email with that attachment? These are the types of questions you want to ask yourself. Give that person a name. You don't need to have to know it. Just give them a name. Call them Bob. Call them Joe. Call them an idiot. Whatever you want to call them, just give them a name so you have an attached identity to what just happened. What are they trying to do with this malware? This is part of the analysis step. So what is the end goal here? What are they trying to do? When did it come in? Where did it come from? Was it necessarily from an email server that you expect? Was it proxied? How did it come in through web? All these different questions. You're trying to start to get a scope of a big picture here. You're essentially painting a portrait of exactly what's been going on. Why are they after your company? Do you have secrets? Do they know something about your company that you may also know, but you don't want anyone else to know? And most importantly, how does it help them accomplish their goal? Obviously, they're using this tool for a specific reason. If they've done enough intel on your company, they're going to know why they're sending a specific piece of malware in and why they think that's going to work against you. What do you do with it all? Put it in a database. Some type of way to correlate that information together so you can identify the trends and commonalities between all the different pieces of malware that you see. What you'll find out is that you'll start to see some trends, and you can start to put these pieces of malware together, and you can say, we just saw Bob use that piece of malware over here, and now he's using this other one. So you can start seeing people changing tactics based on things going around, news that you hear on the internet about people getting attacked, other companies, and you may say, we saw that recently. That's really interesting. These are lots of bits of data you can start to share with each other. So anyone who knows Rounders, if you don't, I highly recommend going to see it, but you're doing a lot of action here, but what have you really accomplished? Well, we're going to talk about identifying and classifying the malware that you've just taken samples of. What does Yara do? Essentially what you do is you take strings and text and you take a binary file, you run it through Yara. What Yara is going to do is going to look for constraints and rules based on that string, and if it finds it, it's going to make sure that those constraints match before it takes a positive ID of that file and return it to you. It outputs that match as a rule. The output can be whatever you want to make it, and based on the output, you can then respond accordingly. Like I said, we're going to talk about Python, and this is pretty much how to use Yara with Python in a nutshell. It's 3 lines. You import Yara. It uses PyYara. It's on the Yara website, which I have the link to the Yara project at the end if you wanted to go get it. You compile your signatures. What's interesting here is that you don't necessarily have to have one signature file. You can actually append multiple signature files together, and when it does the compilation, it puts it all together for you in one nice rule set. You can scan a file. Here, I'm doing a file. You can, use something like URLlib, download web content, stream data through it, check memory, check processes. Anything that acquires data and ships it through and you can do analysis on, you can essentially do it here. And the third step is to profit. So, as the old saying goes, and I'm sure all of you know this, if it walks like a duck and it quacks like a duck, it's most likely the DHA installing backdoor